Hello viewers, and you're welcome to Dynamic Educational Hub channel. And if this is your first time of watching my video, I would like you to subscribe to my channel and click on the notification icon. Alright, in today's video we will be looking at matrices, and this is the first series, which is Introduction to Matrices. Alright, I'm your tutor named Oladimeji Shegun Olawale. Without further ado, let's start the class. Matrices. And what is matrix? Matrix is an array of numbers data in rectangular or square form, where they are arranged in rows and columns. Position of each data is denoted by A subscript ij, where your I represents the row and j represents the column. We have example of matrices here. Now we have A11, A12, A13. Now this is an example of matrix. Now we need to understand row and column. When you have matrix, any arrangement in a horizontal form, you have row. So we have row here. This example of row. This is another example of row, and this one is another example of row. And for column, any arrangement you are making in vertical form, this is 1, this is 2, and this is the third column. While horizontal is your row 1, row 2, row 3. Your column is column 1, column 2, column 3. Like this matrix above here is 3 by 3 matrix. Now let's have our example. Before we solve this, I need to explain another thing again. Now looking at our matrices, we can know the position of the elements of our matrix. Now for instance, if we have 3 by 3 square matrix above here, any element that occupies this position is in first column and first row and first column. Anyone that is here, A12, is first row and second column. The same thing goes with A13, which is first row and third column. So if we continue that pattern for this guy, A21, which is second row, first column. So those numbers I and j are showing us the position of the matrix, the elements in our matrix. The first example, we have 3 by 3 square matrix here. 5 minus 6, 0 minus 1, 0, 3, 3, 8, and 5. In the matrix above, find the value of A11, A31 plus A33. Hi. Then we have A13 times A21 minus A12 times A22. The first question is asking us to find the value of A11, which means the element in row 1 and column 1. As you can see here, this is the row 1, that is row 1, and this is column 1. So the intersection of the two drawn line, which correspond with 5, and if you made the comparison, if we make the comparison here, we see that the element that is present is 5. For number 2 question, we want to find the value of A31 plus A21. So we are adding the two elements together. Now let's find the elements that correspond with that position. A31 means the third row, let's draw it, and the first column, so which correspond with 3. So we have 3 here. 3 is the element in A31. Now A33 means third row and third column, which correspond with 5. So that is why we have 5. We have 5 over here. Now let's solve the math. Here's our 5 here. Now we have A31 plus A33. That gives us 3 plus 5, making 8. The last question, we want to find the value of A13 multiplied by A21 minus A12 multiplied by A22. So we want to solve this. The first thing is, let's find all the elements. Now for A13 means the first row and third column, which is 0. A21 means the second row and the first column, which correspond with -1, correspond to -1. Then we have A12. A12 means the first row we have the first row and the second column, which is -6. Now we have -6 here. Sorry about this, this is supposed to be -6. Now we have -6. Now the next thing is, we need to do our calculations. Now applying board mass, you do multiplication first before any other operation, before your subtraction or addition. Now A13 is 0, A21 is -1, so 0 times -1 minus 6 times 0. So 0 times -1 will give us 0, minus 6 times 0 will give us 0. 0 minus 0, we have 0. Now let's look at types of matrices. Now we have square matrix. This is a matrix that has the same number of row and column. When you have equal number of row and column, we have square matrix. Now square matrix can be of different order. We have 2 by 2 square matrix, 2 rows and 2 column. 2 by 2 square matrix. We have 3 by 3 square matrix. We have 3 by 3 square matrix, 3 row, 3 column. We have 4 by 4. We can as well have 5 by 5, 6 by 6. So once the number of row is the same as the number of column, we have square matrix. Now another example of matrix is row matrix. Now row matrix is a matrix is said to be a row matrix when you have a single row and you have multiple columns. For instance, this type of row matrix I've shown below is 1 by 3 matrix. And for column matrix, a matrix is said to be a column matrix when you have a single column and you have multiple rows. Like this matrix I've shown below, 3 by 1 matrix. Now you have a single column and 3 row. The next type of matrix is rectangular matrix. Now for you to have a rectangular matrix, it implies that you have unequal row and column. When you have unequal row and column, you have rectangular matrix. Rectangular matrix can be in 2 forms. We have vertical matrix for rectangular matrix, so which means that the number of row is more than column. Let's check for this matrix. We have row 1, row 2, row 3, and then we have column 1, column 2. So that gives 3 by 2 matrix. Now this type of rectangular matrix is called vertical matrix. We can also have horizontal matrix. Now for horizontal matrix, we are going to have more column than the row. So for instance, we have 2 rows here and we have 3 columns here. We have 3 columns here. That gives us 2 by 3 matrix. Another type of matrix, which is a special type of square matrix, is triangular matrix. Triangular matrix. For our triangular matrix is a square matrix that has 0 elements. and non-zero elements can form a triangle. If you connect the non-zero element together and it gives you a triangle, you have triangular matrix. So which means that we are not going to have zero elements along the diagonal, along one diagonal. You can only have it at one diagonal. You must not have it at the other diagonal. And then your non-zero matrix must be able to form a rectangle triangle. Another special type of matrix is triangular matrix. Now, triangular matrix is a form of square matrix. So for a matrix to be triangular, it has to be a square matrix. Now, a square matrix that has both zero elements and non-zero elements, and along one of the diagonal you must always have non-zero elements. And if you are drawing a line to connect them together, you must always have a triangle. So that type of triangle is triangular matrix. The first condition, it must be a square matrix, and then one diagonal you must have non-zero elements. You must have non-zero elements. And if you look at the non-zero elements along the diagonal, along the horizontal and vertical, if you connect the three together, you get a triangle. Now, triangular matrix is of two types. We have upper triangular matrix, and then we have lower triangular matrix. If the non-zero element is at the upper part of the matrix, we have upper triangular matrix. For instance, let's look at this matrix here. The non-zero element form a triangle at the upper part of our matrix. So that makes this upper triangular matrix. Now let's look at the other example for 4 by 4. Now we have another triangle here at the upper part of our matrix. Now if you look at the non-zero part, if you look at zero elements, you see that it also forms triangle at the lower part. So we have upper triangular matrix. Then let's look at lower triangular matrix. For lower triangular matrix, your non-zero element will form triangle at the lower part of your matrix. So for instance, let's look at 2 by 2. Now this one is triangular matrix for 2 by 2, lower triangular matrix, and we also have lower triangular matrix here. The knowledge of triangular matrix is going to be vital for us when we want to start solving simultaneous equation involving 2 unknowns, 3 unknowns, 4 unknowns, 5 unknowns. Another type is diagonal matrix. For diagonal matrix is a type of matrix that you have along one of the diagonal you have non-zero elements. Diagonal matrix is a special type of square matrix as well. For you to have a diagonal matrix, it must also be a square matrix. So we have diagonal matrix of order 2 by 2, diagonal matrix of order 3 by 3, diagonal matrix of order 4 by 4. Another matrix is unit matrix. Unit matrix is also a special type of diagonal matrix that you have a unit. You have a unit 1 along one of its diagonal. So 2 by 2 matrix, you have 1, 1, you have 1, 1. So the other element here the other element in your matrix must be 0 for unit matrix. The same thing goes with diagonal matrix. The other element in our diagonal matrix must also be 0, apart from the non-zero element that's spread across, that goes across the diagonal. So we also have a unit matrix of order 4 by 4. Another type of matrix is zero matrix. Zero matrix simply means a matrix that has all its elements as 0. So for instance, 1, we have 2 by 2, we have 3 by 3, 4 by 4. All the elements are 0. The next thing we are going to look at is addition and subtraction of matrix. Now for addition and subtraction of matrix, in order to perform addition or subtraction operation for your matrix must be of the same order. So you can only add 2 by 2 matrix with another 2 by 2 matrix. You can only add 3 by 2 matrix with another 3 by 2 matrix. So the first condition is the order must be the same. Now we have, for example, we have this matrix 3 by 3. We want to add or subtract it from another matrix that is also 3 by 3. It's very simple. Now to solve this, you are going to pick each matrix that occupy the same position and you perform the operation. For instance, which operation do we want to perform? Plus or minus, addition or subtraction. So for us to add these two matrices, we take a look at the elements. Now the first element we are considering here is A1, 1, and it must go along with a B1, 1. So which operation are you performing, plus or minus? So that gives us A1, 1 plus or minus B1, 1, A1, 2 plus or minus B1, 2, A1, 3 plus or minus B1, 3, A2, 1 plus or minus B2, 1, A2, 2 plus or minus B2, 2, A2, 3 plus or minus B2, 3, A3, 1 plus or minus B3, 1, A3, 2 plus or minus B3, 2, A3, 3 plus or minus B3, 3. Example: if A is equals to 3, 2, 2, 1, 5, 1 and B is equals to 7, 5, 2, 0, 2, 3, find I, A plus B, I, B minus A. Now look at this example. This example, we have the same order matrix of order 2 rows and 3 columns. That gives us 2 by 3 matrix. Now let's see how to add them together. So this matrix plus this matrix will give us 3 plus 7, they are in the same position, 2 plus 5, the same position, 2 plus 2, the same position, 1 plus 0, the same position, 5 plus 2, the same position, and 1 plus 3, the same position. After you've performed your operation, what is 3 plus 7? We have 10. 2 plus 5, we have 7. 2 plus 2, we have 4. 1 plus 0, we have 0. 5 plus 2, we have 7. 1 plus 3, we have 4. Let's solve the second question. B minus A. The B of our matrix is 7, 5, 2 minus 7, 5, 2, 0, 2, 3 minus 3, 2, 2, 1, 5, 1. Now we consider the position again. Now 7, what is the operation we want to perform here? We want to subtract minus 3, 5 minus 2, 2 minus 2, 0 minus 1, 2 minus 5, and 3 minus 1. So let's solve this. Now to solve this, 7 minus 3, we have 4. 5 minus 2, we have 3. 2 minus 2, I'm sorry about that. So 2 minus 2, we have 0. 0 minus 1, we have minus 1. And 2 minus 5, we have minus 3. 3 minus 1, 2. We've come to the end of the first series. I would like to do a recap of what we've done so far. The first thing which we discussed about matrices, and matrix is an arrangement of number or data in square form or in rectangular form, where our I and J represents the position of each matrix. We discussed about the position of each matrix using I and J. I represent the row, while J represent the column. We also discussed about different types of matrix. We talked about the column matrix, we talked about the row matrix, we talked about the square matrix, we talked about the rectangular matrix, and we also talked about special types of square matrix, which we discussed about the triangular matrix, the diagonal matrix, and the unit matrix. We went further to do some calculation, which is we did addition and subtraction of matrix, and what is the condition for us that will enable us to perform addition or subtraction operation. Our matrix must be of the same order to perform addition or subtraction operation. We solved some question as well. Thank you for watching this video up to this moment, and if you are yet to subscribe to my channel, please subscribe to my channel and click on the notification icon so when I'm dropping a new video you'll be notified. Alright, thank you guys. You can also check my channel to watch different videos like physics tutorials, chemistry tutorials, and mathematics tutorials. And if you have any comment or you want to chat with me, you can always check the link below this video, and you can contact me directly via my email.